So in this next example, we are going to look at the arc length of a cycloid, which has parametric equations. X is r times theta minus sine theta, and y is r times 1 minus cosine theta, and theta goes from 0 to pi there. So a cycloid curve is formed by rolling a circle along the axis and then seeing what happens to a fixed point on the circle. So let me show you a demonstration of a cycloid curve here. So there is a cycloid curve, and we see one arch of the cycloid. So what we want to find, the length of that. And it seems like, oh, it should just be 2 pi r, the circumference of the circle, but that's not the case. So because it's a little bit different motion than just unrolling a circle. So parametric equations, we know how to find arc length with those. We're using r and theta instead of x. We've got, let's see here. Yeah, we've got r and theta as our parameters. So it's actually 2 parameters. So we would like to simplify things here and consider that we've got a constant radius. So if we've got a fixed radius, then theta is just going to be our parameter. So it'll be things in terms of theta, not in terms of r and theta. So this r is a constant. So just treat that like a number. So then our ds, our little piece of arc length here, so your L then is going to be the integral from alpha to beta of ds, your little piece of arc length, which is going to be an integral from a starting angle to an ending angle. And then it's going to be square root, and then this will be dx d theta squared plus dy d theta squared. And then d theta. So theta is our parameter instead of t. So let's now simplify this piece as much as we can. So down here, let's look at our ds, which is going to be the square root dx d theta. So again, r is a constant, so we can pull that constant out and then take the derivative of this. So r will be on the outside, derivative of theta is 1, derivative of negative sine theta is negative cosine theta, and that gets squared, plus dy d theta. So then again, pull the r off in front, and then derivative 1 minus cosine theta. So r is out in front, derivative 1 is 0, derivative negative cosine theta is sine theta. So this will actually be r sine theta. And that gets squared. And then we want to simplify this as much as possible. So we're going to have an r squared 1 minus cosine squared and an r squared sine squared. So we'll have r squared 1 minus cosine theta squared plus r squared sine squared theta. And then r squared is a common factor there. So we can take and pull that out in front. So this is going to be then square root. Got an r squared out in front. And then 1 minus cosine theta squared plus sine squared. So that quantity squared plus sine squared. And then products we can pull apart. Oops, I need one more parenthesis there. Products we can pull apart. So the square root of r squared is r. And that can come outside the square root. And then we've got to multiply out what's left. So 1 plus cosine theta times 1 plus cosine theta is 1 plus 2 cosine theta. and then plus cosine squared theta. And then we got plus sine squared theta on the end, and then sine squared plus cosine squared theta here is equal to 1. And we'll combine that with the other 1 that's out in front. And we're going to have an r out in front, and then this will be square root 2 plus 2 cosine theta. So 2 plus 2 cosine theta. So there's our ds. So that's what we're going to integrate. We actually can factor a common 2 out here. So this will actually be r, and then this will be square root 2 times 1 plus cosine theta. And then we can break the product apart. So it'll be root 2 times r, that's a constant, times root 1 plus cosine theta. So that is what we're integrating. So then our length here is going to be integral from 0 to 2 pi. So that's 0 to 2 pi here. And then it's going to be root 2 times the radius, and then times square root 1 plus cosine theta. D theta. So these guys can go outside here, and then we want to integrate what's left. Oh, you know what? I made a sign error here. Let's see, this should actually be minus 2 cosine theta, and that'll make this a minus, and this will be a minus and a minus. So this will be minus up here. So now we want to go ahead and integrate this. So what we want to do is we want to look at this 1 minus cosine theta. We want to think of this as 2 times theta over 2. And then that way we can use the half angle identity in there. So I want to bring my root 2r on the outside, and then this will be integral 0 to 2 pi, and then square root, and I want in there 1 minus cosine. Let me move this over, all of this. Cosine of 2 times theta over 2. D theta. So, and then the reason that I did that is, remember our half angle identity is that sine squared theta is equal to 1/2 times 1 minus cosine of 2 theta. Okay, so here we use theta and 2 theta. We could use, if we've got a theta here, then this angle has to be half as much. So it's sine squared theta over 2, which is why they call this the half angle identity. And then this theta here, you can write that as 2 times theta over 2. So you can either look at it here, you know, cosine theta, or 2 times theta over 2. So this is twice the angle, and then the original angle theta. So whichever way we want to look at that. I guess actually we don't need the theta over 2. We can just leave it like that. 1 minus cosine theta is sine squared of theta over 2. So actually this part, the inside there, we can swap that out, multiply both sides by 2. So a 2 here, these guys will cancel. So 2 sine squared theta over 2. So that's actually what we want in here. Sorry about that. So we want a 2 sine squared theta over 2, d theta. So we can break this product apart. The square root of 2 will multiply with this square root of 2 out in front and give us a 2. So I have a 2r out in front. And then we're integrating from 0 to 2 pi. And then square root of sine squared theta over 2 is just going to be sine theta over 2 d theta. So we got our 2r out in front. Now we're ready to do an antiderivative. So if you differentiate sine theta over 2, you get cosine theta over 2 times 1/2. So if we integrate, we're going to get negative cosine theta over 2, and then divide by 1/2, which is multiply by 2. So it's actually negative 2 cosine theta over 2. And evaluate that from 0 to 2 pi. Now the negative 2, we can actually bring that out in front with a 2r. So this is negative 4r. And then we've got cosine theta over 2. And that's evaluated from 0 to 2 pi. So this is negative 4r out in front. Plug a 2 pi in here. We're going to get cosine of pi minus, plug a 0 in, cosine of 0. So cosine of pi is negative 1. Cosine of pi is 1. So this is actually going to be equal to 4r, negative 4r, excuse me, times negative 1 minus 1. So negative 2, which is 8r. So you get 8 times the radius of the circle. So that's pretty cool. So when you roll that circle around one time, the length of this curve is 8 times the radius. Seems like it should be 2 pi r, but it's not. It's 8 times the radius, whatever the radius of that circle is. So, okay, so with these two examples, you should be able to jump in and work on Web Assigned Section 10.2, Problem 4. Give that a try.